Good day. This is Sir Bren, and I'm here to present the lesson for Basic Calculus, Quarter 4, Week 3. The learning competency is to solve situational problems involving exponential growth and decay. But first, let us define exponential growth. Exponential growth is a mathematical change that increases without limit based on an exponential function. Another definition: exponential growth whose rate becomes ever more rapid in proportion to the growing total number or size. A classic example of exponential growth is the growth of the world's population. Next is, what is exponential decay? Exponential decay is found in mathematical functions where the rate of change is decreasing and thus must reach a limit, which is the horizontal asymptote of an exponential function. Another definition of exponential decay describes the process of reducing an amount by a consistent percentage rate over a period of time. So yung exponential decay is the vice versa of exponential growth. Common example of exponential decay is the depreciation of an equipment over time or after long years of use. This lesson is the application of the previous topic, which is differential equation. Sabi dito, let y is equals to f of t. We replace the variable x with t. T stands for time, no? Because we are referring to the rate of change, which is dy over dt in the population y with respect to the time, which is t. And it is given by this one. Dy over dt is equals to ky, where k is equals to B stands for birth rate and D stands for death rate. So sinasabi dito, K is equals to birth rate minus death rate. Then furthermore, if K is positive, that is when the birth rate is greater than the death rate. Ibig sabihin, mas marami yung pinapanganak kaysa sa namamatay. Therefore, dy over dt denotes growth. If K is negative, when B or birth rate is less than the death rate, ibig sabihin maraming namamatay doon sa pinapanganak, meaning it denotes decay. Okay, so from this one, dy over dt is equals to k times y, we will derive the general equation. So dy over dt is equals to k times y. Ang gagawin natin yan is we divide both sides by y. So yung y mapupunta dito sa kaliwa. And then multiply both sides by dt. So yung dito naman, yung dt mapupunta sa kanan. Okay? So yung nasa kaliwa, dy over y can be written as 1 over y dy, di ba? And then yung sa kanan remains. And then next step is to get the integral of both sides. So integral of 1 over y dy, and yung k ilabas na natin and get the integral of dt. So integral of 1 over y dy is ln y is equals to k. So yung integral ng dt is t plus c. So para mawala yung ln sa kaliwa, this becomes the exponent of e. And then yung kanan, ganun din, no? So, therefore, magiging y na lang yung kaliwa. And yung kanan is e raised to k t plus c. This can be written as y is equals to e raised to kt times e raised to c by laws of exponent, di ba? And then furthermore, take note that y sub 0 is equals to e raised to c, or it is a constant. Therefore, replacing e raised to c by y sub 0 dito, magiging general solution natin, it becomes y sub t is equals to y sub 0 times e raised to k t. Or, pwede ring y sub t is equals to c, no? Kasi yung y sub 0 is equals to c din. So, c times e raised to k c. Okay? So, let's give you 3 examples for this topic. Example number 1. Suppose that the colony of lice grows exponentially. So, yun yung assumption, no? After 1 day, 50 lice are counted. And then after 3 days, 200 were counted. How many are there originally? And what is the exponential growth equation for the colony of lice? So, dalawa yung tinatanong dito, class, no? Ano yung bilang niya bago siya naging 200? And ano yung kanyang equation? No? Exponential growth equation. Okay. Take note, the general equation is y sub t is equals to y sub o times e raised to kt. By the way, yung y sub t is the population at any time t, and then y sub 0 is the initial population, and then yung k stands for relative growth rate, and yung t is the time. Okay, from the given problem, we will derive 2 equations, no? So dito, after 1 day, 50 lice are counted. So we have equation 1. So using our equation here, we have 50, no? After day 1. So yung yt niya is 50 equals y sub 0 times e k, and yung kanyang time is after 1 day. Okay, that's equation number 1. For equation number 2, so tingnan uli natin yung ating problem. After 3 days, 200 were counted. So yung equation number 2 natin is 200, no? Yung y sub t, yung left side is 200, and then y sub 0 times e raised to k. So after 3 days daw, kaya yung t niya is 3. So now we have equation 1 and equation 2. Okay, using equation 1, so we substitute equation 1 to equation 2. No? Or yung equation 1 natin, ang gagawin natin dyan, equation 1 is 50 is equals to y sub 0 times e. So gawin na natin siyang 1k or k, no? And then we equate this to in terms of y sub 0. So yung e raised to k mapupunta sa kabila. So y sub 0, 50. Magiging ano siya, no? Denominator siya, e raised to k. Or this can be written as y sub 0, 50. When we transfer this one above, magiging e raised to negative k. Diba? Now, this is still equation 1. Ngayon, ilalagay natin to sa equation number 2, which is this one, no? So, equation number 2 becomes 200. And then, yung kaninang dinerive natin, ito, ilalagay natin sa y sub 0, no? So, 50 e raised to the negative k times e raised to 3k. Okay, so dito kasi siya galing, no? 200 is equals to yung y sub 0, 50 times e raised to negative k, no? And then yung e raised to 3k na siya, no? Ito na siya. Okay, so we compute. So this can also be written as e raised to 3k minus k. And then, so e raised to 3k minus k becomes e raised to positive 2k. And then, so yung 50, lalagay natin sa kabila, 200 divided by 50 is equals to e raised to 2k. 200 divided by 50 is 4 is equals to e raised to 2k. So, yung next move is yung 4, di ba? Pwede natin isulat siya as 2 raised to 2. And then yung nasa kanan can be written as quantity e raised to k squared. Diba? So by mathematical rule that we learned from the previous math, this can also be written as 2 is equals to e raised to k. So dito nakuha natin is e raised to k is equals to 2. Okay, so lagay lang natin dito yung e raised to k is equals to 2 na nakuha natin sa previous slide. So we substitute it to equation 1 again, no? Back to equation 1. So yung equation 1 natin, mapapansin natin dito, ito yun, no? Equation 1. Susulat lang natin siya. So this is equation 1. And then yung kanyang e raised to k is ilalagay na natin yung 2, no? Na nakuha natin dito. Okay? So, masosolve na natin yung y sub 0. Y sub 0 is 50 divided by 2 or 25. Nakuha natin yung sagot doon sa unang tanong. So, the original number of lies before they grew is 25. No? 25 lies. Okay, the second question is what is the exponential growth equation of the colony? So, again, take note the general equation. Diba? General equation natin is y sub t is equals to y sub 0 times e raised to kt. Pwede natin siyang maisulat as y is equals to, yung y sub 0 natin na nakuha is 25. So, place 25 here. And then, yung e raised to k, ito, no? Itong part na yan, is ito yung nakuha natin. No? So, lagay natin dyan, yung e raised to k niya is simply 2 and then raised to t. Okay, so this is the answer for the second question, which is what is the exponential growth equation for the colony? Okay, we have a second example. The rate of decay of radium is said to be proportional to the amount of radium present. If the half-life of radium is 1690 years, and there are 200 grams on hand now, how much radium will be present in 845 years? So again, we write the general equation. General equation is y sub t is equals to y sub 0 times e raised to kt, where y sub t is the population at any time t, y sub 0 is the initial population, k is the relative growth rate, and t is for time. Okay, at present, sabi dito, no, there are 200 grams on hand now. Okay, so this general equation can be written based on the problem as y is equals to 200, no, yung initial population or the initial count, times e raised to kt. And then sabi niya, a half-life, no? If the half-life of radium is 1690 or 1690 years, it will have the initial 200 grams of radium will be reduced to half according to the problem. So, substituting it to the equation, so yung y natin, sabi niya, yung 200 grams will be reduced to half. So, yung 200 divided by 2 will become 100 is equals to 200 e and then raised to k, and yung t niya is na-reduce siya sa half in 1,600 years. Okay, so t natin is 1,690 years. Okay, so ang unknown natin dito is e raised to k. So we equate this one to e raised to k. Okay, so we can further simplify this one. So i-move natin yung 200 sa left side by dividing both sides by 200. So 100 divided by 200. And then yung 200 sa kanan mawawala na. So 100 divided by 200 is 1/2 is equals to e raised to k times 1690. Now we equate this to e raised to k. E raised to k is 1/2 is equals to 1 half. And then yung 1690 na exponent to the other side will become raised to 1 over 1690. Okay? Then substitute this to the original equation, no? Itong nakuha natin. Yung original equation natin is this one. And then we substitute yung nakuha natin na e raised to k to this. So it becomes y is equals to 200. And then yung nakuha natin is yung e raised to k is equals to 1 half raised to 1 over 1690 times t, no, na natitira pa dito. So, i-multiply pa natin siya sa t. Or this can be written as this one, 200 raised to 1 half t divided by 1690. Okay, we solve y by substituting dt is equals to 845, no? So, kasi ang tanong, how much radium will be present in 845 years? So, i-substitute natin yun dun sa t. Becomes y is equals to 200, 1 half, raised to t, which is 845, over 1690. Solving for y, we will get y is equals to 141.4213562, or in 2 decimal places is approximately 141.42. So therefore, after 845 years, no? After 845 years, there will be an approximately 141.42 grams of radiums left. For our last example, example number 3, the number of rabbits in a certain population doubles every 40 days. If the population starts with 12 rabbits, what will the population of rabbits be 160 days from now? So in this example, we will use the doubling time growth formula. So yung doubling time growth formula is P of T is equals to P sub O, and then 2, kasi doubling nga, raised to T over K, where P of T is the population at time T, and yung P sub O is the initial population, and then 2 raised to T, which is time, over K. K is the relative growth rate. So also, dun sa module natin, para pares na rin yung ating variables, no? Ang gagamitin natin dito is y in replacement of p, no? So, ibig sabihin, pwede natin isulat to as y of t, no, is equals to y sub o 2 raised to t over k. So, ang given natin dito, no, yung y sub 0 or yung p sub 0 is yung initial population is 12 rabbits, no? Ito, 12 rabbits. And then yung k, pag sinabing k, ito yung kung kailan siya nagdodoble or nagdodouble. So, it doubles every 40 days. Okay? And then yung t, what will be the population after blank days, which is 160. So, titingnan nyo lang, dapat pare-pares yung ating mga units of measurements, no? Take note. Okay, we substitute this to the formula. Y of t is equals to, what is our y sub 0? That is 12 times 2 raised to t, which is 160, over yung ating k na 40. So, y of t is equals to 12 times 2. Yung 160 divided by 40 is 4. So, y sub t is equals to 12 times 2 raised to 4 is 16. So, 12 times 16 is equals to 192 rabbits. So, therefore, the population of rabbits 160 days from now will be 192 rabbits. Thank you very much and hope you have learned from this lesson. I will see you on my next video. Don't forget to subscribe to my channel and like this video. Goodbye and God bless you all. Thank you.